Download this code from codegive.com, link in the description below. Don't create virtual environments in Python in 2025, maybe. But probably not yet. A deep dive. Okay, let's talk about a somewhat controversial topic, the potential obsolescence of virtual environments in Python. This tutorial will explore why some people think virtual environments might become less critical by 2025, the arguments against that idea, and provide practical examples to help you make informed decisions. I'll stress the might because, as of today, October 26, 2023, virtual environments remain essential, and the conditions necessary for their true obsolescence are far from guaranteed. The core argument, moving beyond dependency hell. The primary reason virtual environments exist is to isolate Python projects and their dependencies. Without them, you quickly descend into dependency hell, where different projects require conflicting versions of the same libraries. This leads to broken installations, difficult debugging, and general frustration. The hypothetical argument against needing virtual environments in the future stems from two main possibilities. 1. Improved system-level package management ** if operating systems, or language-level package managers like pip, could intelligently manage and isolate dependencies across projects without the need for explicit per-project environments, the primary use case for virtual environments would diminish. Think of it like Docker, but much more lightweight and deeply integrated into the operating system and Python itself. 2. A future Python standard library that greatly reduces external dependencies ** if the Python standard library evolves to include a significantly wider range of functionalities currently provided by external packages, the need for external dependencies, and therefore the likelihood of version conflicts, would decrease. Why virtual environments are still essential in 2023, and likely to remain so for the foreseeable future. Before we dive into hypothetical scenarios, let's be brutally honest, as of today, virtual environments are absolutely crucial for managing Python projects. Ignoring them will almost certainly lead to pain and suffering. Here's why. Dependency conflicts are a reality. Different projects will require different versions of the same packages. There's no way around this currently. Reproducibility. Virtual environments ensure that your projects can be easily reproduced on different machines, with the exact same dependencies. This is essential for collaboration and deployment. Cleanliness. Virtual environments keep your global Python installation clean and free from unnecessary packages. This is important for maintaining a stable system. Development versus production. Virtual environments allow you to test new versions of packages without affecting your production environment. Isolation. You can have multiple Python projects running simultaneously, each with its own set of dependencies, without any conflicts. Example of why you still need virtual environments, today. The maybe scenarios, what could change by 2025, and beyond. Let's explore the hypothetical scenarios where virtual environments might become less critical. 1. Improved system-level package management ****. The promise ***. Imagine an operating system or a more sophisticated package manager that automatically isolates dependencies for each project based on a manifest file, example requirements.txt, pyproject.toml, without the need for explicit virtual environment creation. The OS or package manager would manage multiple versions of the same package and transparently select the correct version for each project. Examples of potential technologies, existing and conceptual. Docker, as inspiration. Docker uses containerization to isolate applications and their dependencies. A similar but much more lightweight and integrated approach could be imagined at the system level. *pip with advanced version resolution. *pip could be enhanced to automatically create isolated environments in the background, managed by the OS, based on project-specific dependency specifications. This would be transparent to the user. Current pip still relies on user-created environments. *OS-level namespaces. Operating systems already use namespaces for process isolation. These namespaces could be extended to isolate package installations. *language-specific virtualization. A new layer of virtualization, specifically designed for languages like Python, could provide a lightweight dependency isolation mechanism. *code example, conceptual, not real. *challenges. *security. Ensuring that isolated environments are truly secure and cannot be exploited to access resources from other environments. *performance overhead. Minimizing the performance impact of creating and managing isolated environments. *backward compatibility. Maintaining compatibility with existing Python code and packages that rely on traditional virtual environments. Complexity. Building a system that can automatically resolve complex dependency conflicts without user intervention is a significant engineering challenge. *OS integration. This approach would likely require deep integration with the operating system, which could limit portability. 2. A more comprehensive Python standard library. ****. The promise. If the Python standard library includes a wide range of functionalities currently provided by external packages, example improved HTTP client, better data manipulation tools, more robust GUI frameworks, the need for external dependencies would decrease, reducing the likelihood of version conflicts. Examples of potential expansion. Built-in HTTP client with advanced features. A built-in HTTP client that supports features like asynchronous requests, connection pooling, and advanced authentication. While ERLib exists, it's often considered low-level and lacks the convenience of libraries like requests. Expanded data manipulation capabilities. More powerful built-in data manipulation tools that reduce the need for libraries like pandas, for basic tasks. GUI framework included. A more robust and widely adopted GUI framework included in the standard library, replacing the outdated and limited tkinter. Asynchronous programming enhancements. Further improvements to Asyncio and related modules to make asynchronous programming easier and more powerful. Code example, illustrative, current state. Challenges. Bloat. Adding too much functionality to the standard library can make it bloated and difficult to maintain. Innovation stifling. A comprehensive standard library could stifle innovation in the open source community, as developers might be less inclined to create new packages if the functionality is already available in the standard library. Backward compatibility. Adding new features to the standard library can break existing code that relies on specific behavior of external packages. Scope creep. Defining the boundaries of what should be included in the standard library is a constant challenge. Why virtual environments are likely to be needed in 2025, and beyond a realistic assessment. While the above scenarios are theoretically possible, the reality is that they are unlikely to fully materialize by 2025. Here's why. Legacy code and packages. There is a vast ecosystem of existing Python code and packages that rely on specific versions of dependencies. It would be extremely difficult to migrate all of this code to a new system that doesn't use virtual environments. Open source ecosystem. The Python ecosystem thrives on its vibrant open source community. Developers are constantly creating new packages and libraries. it's unrealistic to expect that the standard library will be able to keep pace with this rapid innovation. Political and social factors. Changes to the Python language and its standard library are subject to community discussion, PEPs, Python enhancement proposals, and potentially lengthy debates. These processes can take years to reach consensus and implementation. Operating system adoption. Significant changes to operating system package management would require widespread adoption, which is a slow and complex process. Best practices for virtual environments, that will likely still be relevant in 2025. Use VNV, or virtualenv for older Pythons. VNV is the recommended way to create virtual environments in Python 3.3 and later. It's part of the standard library, so you don't need to install it separately. Activate the environment. You must activate the virtual environment to use it. Use requirements.txt or pyproject.toml. Create a file, either requirements.txt or pyproject.toml plus poetry.lock or pipfile plus pipfile.lock, to specify your project's dependencies. This makes it easy to reproduce the environment on other machines. Requirements.txt*. Install dependencies from requirements.txt. Pyproject.toml, using poetry. Install dependencies using poetry. Use a package manager, poetry, pypenv, etc. Tools like Poetry and pypenv provide more sophisticated dependency management features than plain pip. They handle dependency resolution, virtual environment creation, and package publishing. Poetry and pypenv use lock files, poetry.lock and pipfile.lock, respectively, to ensure that the exact same versions of dependencies are installed on every machine. These lock files are essential for reproducibility. Deactivate the environment. When you're finished working on a project, deactivate the virtual environment. Include the virtual environment directory in .gitinery. You don't want to commit the virtual environment directory to your Git repository. Add it to your .gitinery file. Conclusion: virtual environments are here to stay, for now. While there's a theoretical possibility that virtual environments might become less crucial in the future, it's highly unlikely that they will be completely obsolete by 2025. The challenges involved in implementing alternative solutions are significant, and the benefits of using virtual environments for dependency isolation, reproducibility, and cleanliness remain compelling. Therefore, my advice is, continue to use virtual environments for your Python projects. They are the best way to manage dependencies and avoid the dreaded dependency hell. Keep an eye on advancements in operating system package management and Python standard library development, but don't abandon virtual environments just yet. Focus on using best practices for managing your virtual environments using VNV, requirements.txt, pyproject.toml, lock files, and package managers like Poetry or pypenv. These practices will ensure that your projects are well organized, reproducible, and maintainable, regardless of what the future holds. And, who knows, maybe by 2035 we'll be writing a tutorial about how to actually abandon virtual environments. But not yet. Okay, let's dive into why you might not need a virtual environment in Python in 2025, and explore the potential advancements that could make them less essential, along with code examples to illustrate the alternatives. Disclaimer: this is a forward-looking speculative answer based on current trends and potential future developments. The actual state of Python packaging in 2025 could be different. The purpose is to explore potential evolutions, not to guarantee future fact. The premise: why virtual environments exist today. Before we talk about a future without virtual environments, let's understand why they're so crucial now. 1. Dependency isolation * projects often rely on specific versions of libraries. If Project A needs Library X version 1.0 and Project B needs Library X version 2.0, installing them globally would create conflicts. Virtual environments solve this by creating isolated spaces for each project, each with its own independent set of packages. 2. Reproducibility * virtual environments, and particularly requirements.txt files or pip files, allow you to precisely recreate the environment a project depends on. This is vital for collaboration, deployment, and ensuring consistent behavior over time. 3. Clean global environment * you don't want to clutter your global Python installation with packages you only need for specific projects. Virtual environments keep your base system clean. The argument, why virtual environments might become less necessary, or obsolete, by 2025. Several factors could contribute to this shift. 1. Advanced package management at the system level **. Containerization integration * by 2025, containerization technologies like Docker and Podman might be so seamlessly integrated into Python development workflows that creating a separate virtual environment is no longer needed. Each project would inherently live in its own container. *OS level package isolation * operating systems could potentially evolve to offer more granular package isolation, allowing different applications, including Python projects, to use different versions of the same library without conflict. Example, conceptual: imagine an OS extension that allows you to tag Python projects. The OS would automatically manage the isolation, making the venv module redundant. 2. Python interpreter improvements * built-in project-specific package stores * the Python interpreter itself could incorporate the concept of per-project package stores. When you run a Python script, the interpreter would automatically look for dependencies in a directory specific to that project. Example, conceptual. 3. Evolution of package managers, pip, poetry, etc. Smarter dependency resolution * package managers could become significantly better at resolving dependency conflicts automatically, without requiring isolated environments. They might use sophisticated versioning strategies and conflict resolution algorithms. Automatic environment management * package managers could handle the environment setup behind the scenes, so developers don't need to explicitly create and activate virtual environments. Example, conceptual: a streamlined poetry-like workflow. 4. Standardized build systems and package formats * unified build tooling * if a single, universally adopted build system emerged for Python, it could handle dependency management and environment creation transparently. More robust packaging * changes in package format, example improving the will format, could allow packages to declare their dependencies in a more granular and isolated way. 5. Cloud-native development * serverless functions * in serverless environments, example AWS Lambda, Azure Functions, Google Cloud Functions, the deployment process typically handles dependency management automatically. Virtual environments are often less relevant in these contexts. Managed environments * cloud platforms are already moving towards providing managed environments where you declare your project's dependencies, and the platform takes care of creating and maintaining the execution environment. Code examples: illustrative, not functional. These are conceptual examples to show how things might work in 2025. They won't run as is with today's tools. 1. OS level package isolation, conceptual. 2. Python interpreter improvements, conceptual. 3. Package manager evolution, conceptual. What it would look like in practice, potentially. Imagine a development workflow where you 1. Create a new project directory. 2. Add a pyproject.toml, or similar, file declaring your dependencies. 3. Run your Python script directly using python my_script.py. The underlying system, OS, Python interpreter or package manager, would automatically install the necessary dependencies. Isolate them from other projects. Ensure that the correct versions are used. Why the shift might not happen completely. It's important to note that virtual environments might not disappear entirely. There are valid reasons why they could remain useful. Legacy projects. Older projects might continue to rely on virtual environments for compatibility. Fine-grained control. Some developers may still prefer the explicit control that virtual environments offer. Complex scenarios. In very complex dependency scenarios, virtual environments might still be the most reliable way to manage conflicts. Portability. Virtual environments can be more portable across different operating systems and Python versions than some alternative solutions. Conclusion. While virtual environments are a cornerstone of Python development today, it's conceivable that by 2025, advancements in operating systems, Python interpreters, package managers, and cloud platforms could make them less critical or even obsolete in many common scenarios. The focus would shift towards a more seamless, integrated dependency management experience. The evolution might not eliminate the need for environments entirely, but it could dramatically simplify the process and reduce the manual overhead. It will be interesting to watch how the Python ecosystem evolves and whether these predictions, or something similar, come to fruition.